Let's do some problems related to complementary angles. So here's the first one. So we're going to use one common trick for all the problems that we encounter in this particular section. And if you really get that, it becomes very simple. So what we need to do is to find out all the complementary angles. So here in this case it's 47 and 43, right? So what that means is, you know, this and this are interrelated. That's a hint for you. You know, the next one is, let's say 72 and 18, they add up to 90. You know, they add up to 90. That's what we mean by complementary, right? So this and this are interrelated. So straight away you get a hint. All problems, you know, I would urge you to look for that hint and underline, you know, so you know they are interrelated. And the interrelationship is typically, you know, it's something like this. You know, sine of theta is, since it's cos of 90 minus theta, we know that sine of 43 would be cos of 90 minus 43. That's cos 47. And similarly, you know, sine of 72 degrees would be equal to cos of 90 minus 72. That will be cos 18 degrees. So we can substitute it in our equation. You know, that sine 43 is cos 47. So let's do that. Cos 47 degrees divided by cos 47 degrees plus, you know, sine 72 degrees is nothing but cos 18. So let's straight away substitute that. It is cos 18 degrees divided by cos 18 degrees. Oh, sorry, there's a whole square here and here, so let's have this whole square. Minus, it doesn't really matter even if it is not a square because it's 1. So 2 into cos 45 is 1 by root 2, the whole square. So that is 1 plus 1 minus 2 into half. That will be 1, because this will be 1 and 1 plus 1 minus 1 is 1. So that's the way to approach this problem. So let's do the next problem. So here is the next problem. So the first task is to find the complementary angle. And here I think, you know, these two looks like the complementary angles, and of course same as here. So some way we know that this and this are interrelated. So straight away we know this. So let's see how that interrelationship is. You know, we know that secant theta is, you know, secant theta is nothing but cosecant 90 minus theta. So in other words, we know that secant 70 would be equal to cosecant 20, and cosecant 20 is nothing but 1 by sine 20. So straight away we have found our relationship, you know, to the sine 20. So we have found our relationship. So we can write our secant 70 as 1 by sine 20. And similarly, let's try to find out what would be the relationship for cosecant 70. We know that, you know, you can do it in two ways. You can straight away say that, you know, if you don't like complementary angle in cosecant and all, you can straight away convert it. This will be nothing but 1 by sine 70, and 1 by sine 70 would be equal to 1 by cos of 90 minus 70, which is 1 by cos 20. So we know both of them. So now it's a matter of substitution. 1 by sine 20 into sine 20 plus cos 20 into 1 by cos 20, that's equal to 2. That's our answer, right? Expression equal to, right? Right. So that's how easy it is to find your find your answers once you know what the complementary angles are. So let's do the next problem. So this is a proof question, and whenever you get a proof question, you can try to find out what is your left hand side evaluate to, and try to find out what the right hand side evaluates to, and see if you both meet at the same point, right? So let's start that. So LHS is, we know that sine of 90 minus A equal to cos A. That's something we know, and this is nothing but sine A. So LHS would be, LHS would be equal to cos A sine A. Now let's find what RHS would be. So let's say this is tan A by 1 plus tan squared A. So that will be equal to, you can substitute tan A as sine A by cos A divided by 1 plus sine A by cos A, the whole square. This is sine A by cos A into 1 by cos squared A plus sine squared A by cos squared A. We know that this quantity is 1, so we can write this is sine A by cos A into cos squared A divided by 1, because this quantity is equal to 1. Now cancelling, we get cos A sine A, which is our second deduction. So we say that since LHS equal to right hand side, hence proved. Now this is very important to write, right? So this kind of tells that, okay, I have proved it by finding that LHS and RHS are same. So though this may look very customary, but it's an important thing to write. People look forward to seeing this. So let's do one more problem, and before we wind up in this video. So this question looks pretty hard and tricky, but you'll soon realize that this is pretty straightforward. If you look at this, you somehow need to be able to relate this to this quantity. And the way to go about is, if you're not very sure, you take one step at a time, right? So let's say, this implies that our cos 38 into 1 by cos 90 minus 2a is equal to 1, because secant is 1 by cos. Or in other words, you straight away get cos 38 equal to cos 90 minus 2a, and there you go. So that implies that 90 minus 2a equal to 38 degrees, or 90 minus 38 equal to 2a, or a equal to 90 minus 38 would be 52 divided by 2, that is 26 degrees. So sometimes a problem may look intimidating, but if you take the first step, then everything probably falls in place. So that's one strategy. Alright, so let's do some checkpoint questions. I urge you to solve them and write the answers in the comment section. And see you in the next video with more problems.